Okay, in this video we're going to go over verifying identities. Right, in this module we're introduced several new identities like double angle, half angle, and such. So we're going to use those to verify even more identities. Right, as a refresher, when the prompt is verify identities, we want to stick to just working on one side of the equation. Right? Even though we see an equal sign, we are assuming we are not sure whether this holds or not. All right, our aim is to prove that it in fact is true. Right, so stuff like moving things from one side of the equation to another is strictly forbidden, right? Because we want to show that this actually is true. Okay, so we want to just stick to working on this side or that side, and there are some guidelines to kind of choose a side, right? There's no particular rule that says you have to work on one particular side over the other. In some cases, right, depending on who you are, right, or how you see this problem, some things might pop out and be like, oh, this side is easier, right? In some cases, it should be obvious, I think. In this case, there's not much to work with here, right? We just have a negative cosine theta. Right here we have a difference of two angles in the side the cosine, right? So there's at least something I can do, right? So here I'm going to stick to one side. In particular, here I'm going to work on the left side, right? And I'm going to apply the difference formula. Right, so that's again one step at a time. Right, so I'm going to apply difference formula. Okay, so either you recall it from memory or you look it up. Right, we're at home. We have there's a page on our module listing all of the identities. So in this case, the applying correctly the formula we have. Remember, it's not cosine theta minus cosine pi theta. Right? That is not how we do something like this. Applying the formula correctly. Oop. And that would be plus. Okay, and then here, looking at this, now we look at the cosine of pi, sine of pi. Those are values on my unit circle, right? That hopefully by now I memorized, or you can at least recognize, oh, I can find the value of that pretty easily, right? And the value of 0, again, I don't know what theta is, right? It's some angle. Okay, so we leave it as is, right? So 0. So we simplify is our next step here. And actually here, let me sine theta times 0. Here cosine of pi, that is -1. And again cosine theta. All right, and now let's simplify one more time, right? Simplify again. 0 times any value, right? Whatever that value of sine is, it's still 0, so that part goes away. And then here cosine times -1 is simply negative cosine theta. So you can rewrite this in this fashion here. All right, and now we have proven the identity. This side is exactly the same as this side here. So that completes that problem here. All right, let's jump to another example here. Right, so in this case, here we have cosine theta plus sine theta. That quantity squared equals to 1 plus 2 sine theta. All right, so again, I'm going to kind of draw a straight line here, kind of section off to just remind myself this is completely split. Right, I'm going to stick to one side here. And again, feel free to work with either side. Right, looking at this for me, I think, well, this gives me more, it's more complicated, right? Or in the sense that there's more to do. Right, so the first thing I'll do is I'll just simply rewrite this just to recognize that this squared part, right, so the first step I'm just going to rewrite. So I'll rewrite. We have cosine theta plus sine theta times cosine theta plus sine theta. Okay, so I just rewrite this right here, right, to see that this is in fact what is represented here. All right, and now I'll expand, right, or FOIL, or the distributive property, however you want to call this. All right, so here, expand. Okay. All right, so here, when we expand, cosine theta times cosine theta, cosine squared theta, all right, cosine theta times sine theta, and those are two different factors. So we just write like this. All right, didn't plan how much room I needed here. Okay, so I'm just gonna continue here on this next line here, and then continue distributing. So sine theta times cosine theta. Again, two different factors, so we just rewrite like this. And finally, the last factor, sine theta times sine theta, sine squared theta. All right. And now my next step here is going to be to combine like terms. All right, and this cosine squared theta doesn't have a like term, so I'll just rewrite it here. And neither does this sine squared, so I'll just actually group it here. Right. But these two, they are like terms, right? They have exactly the same factors, right? Even if they weren't in the same order, if it was, let's say, sine theta, cosine theta, right? It's multiplication, right? So remind yourself, 4 times 3 is the same as 3 times 4, right? So the order doesn't matter, right? When we're talking about multiplication. To determine that they are in fact like terms, I have one here and one here for a total of sine theta, cosine theta. All right. Okay. And now, at this point, I can apply some identities. Here we see our Pythagorean identity. So cosine theta plus sine squared of theta. I can replace that, right? That is equivalent to 1. Right, so this here becomes 1. And then looking at this, right, if it's, again, right, it's helpful for now. Right now, for myself, I've done this so long that I just see these in my sleep sometimes, right? This, right away, I see that and I'm like, oh, that is actually sine of 2 theta. But again, please have a list of identities by your side, right? Whether you print the ones that I posted there on Canvas or just have the window open so you can kind of glance at them and see, all right, that's that identity here. And now we are done. We are at the point where the left side here is the same as the right side here. So that completes our problem. Thank you.